Alright, let's do our Chapter 1 review sheet here. Okay, horizontal transformations will be those inside the parent function, inside the x squared. So there's a 4 and a minus 3. And the stuff inside works in reverse order according to the PEMDAS, or order of operations, and it also works opposite of what you would think. So PEMDAS says multiply first and then subtract 3. And so we're going to do the subtract 3 first. That's opposite order of PEMDAS. And a subtract 3 you would think would move it to the negative 3, but it actually moves it to the positive 3. So this is shifted right 3, and then the second one would be by the 4, and the 4 times seems like it would make it 4 times as wide, but it makes it 4 times as narrow, and this is all relative to the x-axis, so it makes it moves every point four times closer, or as 1/4 as far far from y-axis. So it's all going to be related to the y-axis. It's going to move. Stuff on the left side of the y-axis is going to get closer, and stuff on the right side of the y-axis closer by a factor of 4. Now the vertical is everything outside the parent function, outside the x squared, where that's a minus and a 2 and a 5, and these do go in order of operations. And so the multiplication would come before the addition. So first of all, we'll take care of the minus, which is a vertical flip or reflection over the x-axis. And then the 2, you would think it'd make it a vertical stretch, and it does. It moves everything 2 times as far from the x-axis. The stuff that's above the x-axis will go up, and the stuff below the x-axis will go down twice as far. So vertical stretch by 2 from x-axis, and then at the final is plus 5, so that's a shift up 5. It's a plus 5, and everything does like it looks like it would. So there is number 1. Number 2, find the x-intercepts. If you could factor this, that's the way you would do it, but since this doesn't factor and you're making y be 0 to find x-intercepts, means we have to figure out how to get 2x squared minus 3x minus 6 to equal 0. So this calls for the quadratic formula, since this doesn't factor. So it's the opposite of b. So the opposite of negative 3 is 3, plus or minus the square root of b squared. So negative 3 times negative 3 is positive 9. Minus 4 times 2 is minus 8, times negative 6, because it's negative 4 AC. Negative 8 times negative 6 is positive 48. And all over 2 times 2, which is 4, 2a. 2 times 2 is 4. So 9 plus 48 is 57. So we got 3 plus or minus the square root of 57 all over 4. So it's 3/4 plus or minus the square root of 57 divided by 4. Okay. The log rules. Changing a log. So if I had the log base b of a equals something, to change that to a power equation, that would be b to the c equals a. To what power do I take b to get a? B to the c equals a. B to the c equals a. B to the c equals a. Log product rule. If I have the log in some base of a times c, it becomes log in that same base of a plus log in that same base of c. Logs are powers. The powers of two things multiplied, you add the powers. Add the power to the power. The log quotient, when you have the log of two things divided, when you divide, you subtract the power. So it becomes the log base b of a minus log base b of c. The exponential rule. If you have the log base b of something to a power, you multiply the powers. The power to a power, you multiply them. So it becomes c times the log base b of a. And if you're trying to look up, figure out the actual value of a log base b of c, and these are not numbers that you can do very well, then you can do it by changing it to any base you want, base e or base 10 normally, because that's what's in your calculator. Base, I'll make it any base you want. I'll call it a. Log of the argument, c, divided by the log in that same base of the base. So now, using those rules, how can we make this go to be a single log? They're all log base 3, so we don't have to do any change of bases. But we have a 2 in front, so we'll move that up as a power. So this becomes log base 3 of 5 minus log base 3 of x to the 2, doing the power rule backwards, plus, there's nothing in front here, so we got log base 3 of x plus 2. This is subtraction, and when you subtract the logs, it goes back to division, so this becomes log base 3 of 5 divided by x squared for these two. And then this is adding, so this goes into multiplying, so it becomes log base 3 of 5 over x squared times x plus 2. And you could try to reduce that, but that's fine. Just getting it there. We wrote it as a single log as it is. Okay. Number 5 is to see if you understand the difference between these types of equations. When x is just the base, this should be able to do it with simple algebra 2 stuff. Divide both sides by 3 and we get x to the third equals 3. And then to get rid of the power of 3, we take the cube root, or to the 1/3 power, and we get x equals 3 to the 1/3, or cube root of 3. And it's not plus or minus on the cube root. If it was square root or fourth root, then we'd have to put plus or minus, but not cubed root or fifth root or on any odd root. Now this one we can divide by 3 like we did before, and we get 2 to the x equals 3, dividing both sides by 3. Now to solve for a power, we use logs. And we'll just use the first rule on how to write a power back as a log. So this says, to what power do we take 2 to get 3? And that's x. So x is this, and if we actually wanted the decimal value of this, we'd use the change of base rule to do it on the calculator, and we could write it as log in base 10 of 3 over log in base 10 of 2, or log base e, ln 3 over ln 2. And that will come up with a decimal value. You should be able to get the decimal value on that. Now C is much trickier, since now we don't have same bases and we have x's on both sides. We could try moving that over, but we still can't combine them because they don't have the same bases. And dividing by 3 won't make it any better to have a 1/3 over here as a 3 over here. So we go to how to change to a common base, using the idea that 3, and I'll do it in base 10 because that's probably makes most of you happy. 10 is 3 is 10 to the log base 10 of 3. That's another name for 3. You can type that straight into your calculator and you'll see that comes out to be 3. Times 5 would be log 10 to the log 5. And then that would be to the x power. And then we have equals, and 2 is 10 to the log 2 to the x plus 2 power. Now, when we got a power to a power, we multiply. Power to a power, we multiply. So this becomes 10 to the log 3 times 10 to the x log 5 equals 10 to the log 2 times x, which is x log 2, and log 2 times 2, which is plus 2 log 2. Now we could put the 2 back up as a power, and this would be just a log 4. So this, and then what do we do when we got it multiplying? We add the powers. So we got 10 to the log 3 plus x log 5 equals 10 to the x log 2 plus log 4. Now, since that's the single base on each side and it's the same base, the powers must be equal. So we have log 3 plus x log 5 equals x log 2 plus log 4. Now, since we're trying to solve for x, I will get all the x's on the same side, so I'll bring this one over and I'll subtract the log 3 from both sides, and so I'm going to get x log 5 minus x log 2 equals log 4 minus log 3. Alright, now I can factor the x out of this, and I'll have x, and log 5 minus log 2 would be left, and that can be written, the minus would be a division, so it's the log of 5 divided by 2, or 2.5, equals, and here's subtraction, so that would be log of 4/3. And so then I just divide by log of 5/2, and I get x equals log of 4/3 divided by log of 5/2. So that's the hardest problem on the first page. Second page, now we're into the trig stuff. How well do you remember it? Pi over 6. Pi is a half a circle. A sixth of 180 degrees is 30 degrees. Pi radians is 180 degrees. 180 divided by 6 is 30. Okay, so the cosine of 30 is, these are all special angles, so the cosine of 30, if we're thinking about the unit circle, 30 is here, and this is square root of 3 over 2 half. The sine is, oh no, excuse me, the cosine is square root of 3 over 2. The y direction is the sine, that's 1/2. And the tangent is the sine over the cosine, so that's 1 over the square root of 3, or 1 over 2 over square root of 3 over 2, which reduces to this, or square root of 3 over 3. Secant is the reciprocal of cosine, so it's 2 over the square root of 3. If you were to rationalize that, that'd be 2 square root of 3 over 3. You don't have to. Cosecant is the reciprocal of the sine, so that's just 2 over 1. And cotangent would be 3 over the square root of 3, or square root of 3 over 1. 135, that's 45, 45, 45. That's here, that's 45 is pi over 4, so that's 1/4, 2/4, 3/4. 3 pi over 4 radians. There, the sine and the cosine are the same size, but the cosine is negative. Negative 1 over the square root of 2, or negative square root of 2 over 2. The sine would be up 1 over the square root of 2, or square root of 2 over 2. Tangent will be the ratio of these, which they're both the same except one's negative, and so it's -1. Secant is negative square root of 2. Cosecant, reciprocal of sine, is square root of 2. This was negative. And then the cotangent would be -1 also. The reciprocal of -1 is -1. Where is the cosine 1/2? If we go out half in the x direction, cosine is the x direction, that would happen at pi over 6 or negative pi over 6. I'll do the pi over the 6, pi over 3, excuse me, which is 60 degrees. That's where the 6 I was talking about came from. So that's 1/2, and this is square root of 3 over 2, and then the tangent would be square root of 3 over 1, or square root of 3. And then the reciprocal of 1/2 is 2. The reciprocal of square root of 3 over 2 is 2 over the square root of 3, or 2 square roots of 3 over 3. And the reciprocal of square root of 3 is 1 over the square root of 3, or multiplying by square root of 3, numerator and denominator, square root of 3 over 3. When is the sign negative square root of 2 over 2? Well, it's positive at 135, so it would be negative at down here. That's 45, 45, 45, 180 plus 45, 225 is one place. There are other answers for it. It would also be negative over here at negative 45 or 315. But we'll go with, I'll just go with the 225, which makes the angle 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And there, the cosine is negative square root of 2 over 2, or 1 over the square root of 2 negative. This is the same as negative 1 over the square root of 2. So the tangent, since these are both negative, is going to be positive 1. The secant will be negative square root of 2. The cosecant would be negative square root of 2. And the cotangent would be 1. Tangent, undefined. That's when we'd have division by 0, when the sine is 0. When the y height is 0, that would be either at 0 or 180. I'll just use 0 degrees, which is 0 radians, which the cosine in is 1, the sine is 0, the tangent is undefined. Secant is the reciprocal of cosine, which it would be 1, this is 1 over 1, so the reciprocal is 1. This is 0 over 1, so the reciprocal is 1 over 0, or undefined. And the reciprocal of this, that's 0 over 1, becomes, 0 over, got this backwards here. Hang on. Tangent is sine over cosine, so that has to be 1 over 0. Ooh, boy. Sorry about that. So this is undefined. And the reciprocal of 1 is 1. Messing up here. Don't want to do that. And the reciprocal of the undefined 1 over 0 becomes 0 over 1, or 0 for the cotangent. And then finally, cosecant is negative 2. So that means the sine is negative 1/2. And sine is negative 1/2 right here. So that's like down pi over 6. So I could go negative pi over 6, or negative 30 degrees. Or I could do 330, or I could do 180, 210, or negative 150. Bunch of different possibilities. I'm choosing to do this one. So the sine would be negative 1/2. The cosine would be square root of 3 over 2. The tangent be the sine divided by cosine, negative 1 over the square root of 3, or negative square root of 3 over 3. Secant, reciprocal of that, is 2 over the square root of 3, or 2 square roots of 3 over 3, and 2. And the reciprocal of this is negative square root of 3, or 3 over the negative square root of 3. Those, kind of remember those. Sine squared plus cosine squared. That's the Pythagorean Theorem in trig, and that's a squared, y squared plus x squared equals 1 on the unit circle. The sine of two angles added is the sine of the first one, cosine of the second, plus the same addition sign, keeps the same, the cosine of the first, sine of the second. That's it. Sum formula for two angles and the sine. The cosine one is cosine the first, cosine of the second, and it's always opposite sign, so this is plus, it would be minus sine of the first, sine of the second. Sine of 2x. Well, if both of these were x's instead of y, we have sine x cosine x plus sine x cosine x. So it's 2 sine x cosine x. Cosine 2x. Well, if these are both x, we'd have cosine squared x minus sine squared x. And you could either replace the cosine squared x with 1 minus sine squared from this, or you could replace sine squared with 1 minus cosine squared, and you would get two other formulas that are possible. And what is 1 minus sine squared? Well, 1 minus sine squared is cosine squared x, just like 1 minus cosine squared is sine squared. So those are some of the basic identities. And now let's go to solve this. Sine of 2x equals a half. So let's think of this as the sine of some angle is 1/2. Well, the sine is a half in lots of places. Sine is the y coordinate on the unit circle, and so the y has to be half. That happens at pi over 6 plus 2 pi k, multiples of 2 pi there, plus 2 pi, plus 2 pi, plus 2 pi, or back to 2 pi. And it also happens at pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, plus 2 pi k. Now, but theta was 2x. So if we replace theta with 2x and then divide both sides by 2, we get x has to be pi over 12 plus, and 2 pi k divided by 2 is pi times k. And we get the other set of answers, or 5 pi over 6 divided by 2 is 5 pi over 12 plus 2 pi k divided by 2 is pi k. Simplify. So we have the cosine of x, tangent squared. Tangent is sine of x over cosine x squared. So we have sine x over cosine x. And this is divided by sine x secant, which is 1 over cosine x. So this is just sine over cosine, which cancels one of the sine over cosines. And this cosine cancels that cosine, and we end up with sine of x. Solve secant of x equals 2. So this says, what angle can we take the secant of and get 2? Secant is 1 over cosine x equals 2. So if we take the reciprocal of both sides, we get the cosine of x equals 1/2. And cosine is 1/2 at pi over 3 and negative pi over 3. So we get plus or minus pi over 3 plus multiples of 2 pi k. So here we were looking for an angle where 1 over the cosine of the angle was 2. Now this is the inverse cosine of a half. So we take the cosine of both sides and we get 1/2, because the cosine is the opposite of the cosine inverse, is equal to the cosine of x. So now we got exactly the same problem. So it has exactly the same answer, unless we're just looking for the principal value, which would have been pi over 3, but all the possible answers are plus or minus pi over 3 plus 2 pi k. And finally, can you graph the sine with these transformations? Okay, so we have a 0.5 on the inside of the sine function. First of all, what's the sine function look like? Well, it starts at 0, goes to 1 at pi over 2, goes to 0 at pi, goes to -1, and then back to 0 at 2 pi. .5 on the inside. So you would think multiplying by 0.5 would make it half as wide, but it makes this twice as long. So this goes now, it would take clear till 4 pi to make a single wave. Now we're on the outside. A 2, we do them in order, not the +1 first, but the 2 first. So that would make the amplitude be twice as much, a vertical stretch of 2. So instead of going from 1 to -1, it'll go from 2 to -2. And then we're supposed to shift it up 1. And so our final sine curve would be, have a center line of not 0, but of 1. And going up 2 from there, so that would go up to 3. And then back down, and then down to -1 and back up. So that's, because that would be 2 below it. And back, and it would take 4 pi to complete that. So it has a period of 4 pi, an amplitude of 2, a period of 2 pi divided by half, which is 4 pi, and a vertical shift of 1.